Howdy! This is your friendly neighborhood physics teacher here, and this is our second video of the force review video, or the final review videos. The first one kind of gives you a brief overview of what to expect for the exam, so if you haven't watched that one, I believe that one's the torque. If you haven't watched that one, go back and watch it. So, momentum. So this little chart was at the beginning of your review. The reason we did this is because we are going to give you the equations, but if you don't know what the variables and units are, it's not going to help you. So the first one was your variables. This was your units. And then this was your equations. So let's just go through them real quick. Mass is represented with an M, measured in kilometers. Velocity is represented with a V, measured in meters per second. Initial velocity is represented with a VI, still measured in meters per second. Final velocity is measured with a VF, still in meters per second. Momentum is represented with a P, lowercase p, and it's measured in kilograms meters per second. And your equation for that is P equals mv. Now, you do have another one, and it's dealing with change in momentum. So change momentum equals your mass times change in velocity. So here we go. So elastic collision is when things hit and kind of bounce off. So in inelastic collision, so you have two objects. You have M1, VI1 plus M2, VI2 equals M1, VF1 plus M2, VF2. And you can solve for any of those using that equation. In inelastic is when things stick to each other. So they don't necessarily start out together. So you have M1 times VI1 plus M2 VI2 equals, and the two objects stick together, and you just get one final velocity because they're going at the same speed because they're stuck together. Impulse. Impulse is represented with a J, and that is measured in Newton seconds. And your equation would be impulse equals force times time. Now, there is an equation that connects these two. There's an equation that connects these two. Because your change in momentum equals your impulse. So therefore, your mass times change velocity equals your force times time. And since that is, you can make all kinds of different. So your change in momentum can equal force times time, and your impulse can equal mass times change velocity. It's interchangeable there. And since that's interchangeable, that means your units are interchangeable too. So your unit for momentum can also be, Newton's seconds. And your change, or your equation, your units for impulse can also be kilograms meters per second. So a little bit of interchangeable there if you're dealing with change in momentum. Yeah. So time is represented with a lowercase t, and it's measured in seconds. And again, a force is represented with a capital F, and it's measured in newtons. So hopefully that kind of refreshes your memory for momentum there a little bit. Again, don't forget about the interchangeable mess over here. So a couple of conceptual questions to start out. Why is there foam in helmets? So most helmets, like football helmets, baseball helmets, even bike helmets, have between, you have the outer hard plastic, you have foam, and then sometimes you have inner plastic, or that's kind of a little bit not as hard, it's a little bit more movable, or your head's just right on the foam. But what's the point of that foam in the helmets? So you got to think about what happens when you have, so the foam, usually have like little pockets of foam here. So what happens to the foam when you squish it? So if you sit there and squish foam, you can do this, like grab your pillow and squish the pillow if you're doing. So it when you squish it, it gets smaller, and when you release it, it gets bigger. You have that movement there. So basically, what the foam does, it absorbs. It absorbs the energy, and it absorbs energy. So that energy that the foam's absorbing is not getting to your head. So it's taking energy away from the system that could possibly have been put on your head. So it's absorbing energy, so it's protecting your head. It's the biggest thing. So it absorbs that energy, so that energy is not going to your head. So 2, what is the equation that goes with this picture? Now we have to decide, is an inelastic or an elastic collision. So before the collision, we have 2 objects. After the collision, it looks like we have 1 object. So that looks like it becomes an can't spell, an inelastic collision. So it becomes inelastic. So the main equation you're going to be dealing with is M1 VI1 plus M2 VI2 equals M1 plus M2 V final. So now we can, and it says what equation goes with this picture. So we can kind of plug in what we got. So M1 turns into MA, and VI1 just turns into V, plus we had a lowercase a. Make that an uppercase a. So lowercase a, and it doesn't show that it has a velocity, so our velocity would be 0 at standing still. And so we have M capital A plus M lowercase a, and our final velocity is just V with a dash. So 0 times anything goes to 0, so that goes to 0, so that can go away. I'm going to need some more space. Give me some more space, please. I'm going to need some more space. Space. There we go. So that leaves us with M capital A V equals M capital A plus M lowercase a V with a dash. And if we're solving for kind of like with V with a dash, because we're solving for our final velocity, we can go ahead, and since that's being multiplied, the opposite multiplies divide. So you can get MA plus M lowercase a, and divide that by M capital A plus M lowercase a. Those cancel out, so your V with a dash equals M capital A V divided by M capital A plus M lowercase a. So you're just manipulating the formula without using numbers. You would do it just the same way like you would do with numbers. So that's kind of what to expect for number 2. Number 3, you're trying to teach your dog to run and jump on a skateboard for a local talent show. The mass of your dog is 30 kilograms. The mass of the skateboard is 10 kilograms. Your dog runs at a velocity of 5.6 meters per second, what is the final velocity of your dog on the skateboard? Dog on the skateboard. So let's do some givens. So our givens, you have mass of your dog. So we can do MD equals 30 kilograms. Mass of skateboard, so we can go MS equals 10 kilograms. It says velocity of your dog. Now this is as it's running, so that'll be your initial velocity of the dog. Let me flip those, sorry. Your initial velocity of the dog is 5.6 meters per second. Give me some more room. More room. There we go. And so your dog's running towards the skateboard. So you can assume that your initial velocity of the skateboard would be 0. And what you're looking for is the final velocity of the skateboard and the dog. So your dog on the skateboard. So it's combined. So right there, dog on skateboard. So that's telling you, right there, that is telling you it is an inelastic collision. So you're looking for your final velocity, which you know would be in meters per second. So the equation that you're going to end up using would be m1 times vi1 plus m2 times vi2 equals m1 plus m2 equals v final. Now, does it matter which ones you make m1 and m2? Nope. As long as the ones and the twos stay together. So I'm going to make the dog m1. So that means the velocity of the dog is going to be vi1. Skateboard's going to be m2. So that means the initial velocity of the skateboard is going to be vi2. So now that we have that, and of course that just stays our v final. So now that we have our givens kind of going with our equation there, we can plug in. So M1 is going to be 30. VI1 is going to be 5.6. V2 is going to be 10. Our VI2 is going to be 0. V1 goes going to be 30. M2 is going to be 10. And we're looking for our final velocity. So at this point in time, let's kind of simplify. So let's do 30 times 5.6 in your handy dandy calculator. 368 plus 0 times anything gives you 0 equals 30 plus 10 gives you 40. V final. And we're looking for the V final. That's what we're looking for. So we need V final by itself. It's being multiplied. The opposite of multiply is divide. And what you do to one side, you have to do to the other. So your V final was going to be 168 divided by 40. You get 4.2 meters per second. So that's how fast your dog on the skateboard is going. Woohoo! So I hope that helped with that. Now, why would it hurt more to catch a ball thrown by Nolan Ryan in his heyday versus a 5-year-old? Now, if you know, hopefully you know Nolan Ryan. If you're not a baseball player or baseball fan, Nolan Ryan was a famous pitcher. He's still around. The reason I picked Nolan Ryan is he's still involved in a lot of things in Central Texas or in Texas in general. So that's the only reason why I picked him. He's still involved in our community today. And but Nolan Ryan, I used to know how fast he could throw, but he was one of the fastest pitchers of our times. And then you have catching one of his balls, and then you have a 5-year-old throwing a ball at you. So which one would hurt more and why? So of course Nolan Ryan would hurt more. And the reason is because he's able to throw faster. So he's able to throw faster, given the same ball. So it's the exact same ball. So the masses are the same. Oh, I put a T in same. Are the same. But Nolan Ryan can throw faster than a little 5-year-old can throw. So if we look at our equation, momentum equals mass times velocity. So if you increase velocity, keep mass the same, you're going to end up increasing your momentum. Because there is a change velocity, because it goes, so change momentum. And going back, that your change momentum also equals force times time. If you're increasing that momentum, you're also increasing the force. Because another way to think about it is who's going to be able to throw faster too. And so that's decreasing that time. So you're getting more force. So it's just because the change in momentum is greater. So that's the big answer there. Do. Anything. So your change in momentum is bigger with Nolan Ryan. So that's like your main answer there. There we go. So what is the relationship between momentum and velocity? We kind of talked about that. We just talked about that. So your momentum is mass times velocity. So if we keep mass the same, we increase velocity, we're going to end up increasing momentum. Decrease velocity, we're going to end up decreasing momentum. So that is a direct relationship. So what's the purpose of the crumple zone in a car? That can refer back to the foam. So the crumple zone absorbs that energy. So it absorbs the energy and of the crash. It just absorbs that energy of the crash. So not all that energy is going into you. It's mostly going into the car before it gets to you. It's just a safety mechanism. What is the impulse? Oh, so we're looking for what is the impulse of an object that is 80 grams and is initially moving at a velocity of 6 meters per second when it touches the net and stops within 40 centimeters. I need some more room on this one. I foresee. Here we go. So let's write out our givens. So it gave us that the object's mass is 80 grams. It's initially moving at 6 meters per second. It comes to a stop, so we know that the final velocity is 0, and it touches and stops within 40 centimeters. So it gave us a distance of 40 centimeters. And it says, what is the impulse? So our unknown is going to be impulse which is newtons seconds. So a couple of things to look. Do we like grams? Hopefully you're saying no. So we need to convert from grams to kilograms because we like kilograms. So we need to go to kilograms. If remember, kiss her daily because divorce costs money. We're at grams. Grams is a base, so we're at because. And what we want is kilo. So you're just going to take your decimal and you're going to move it over 1, 2, 3 spots. You're going to take your decimal and move it over 1, 2, 3 spots. If there is a blank, you're just going to put a 0 there. So your answer is going to be 0.08 kilograms. Another thing is, do we like centimeters? Nope. We like meters. So we need to convert that to meters. Centimeters is here. Meters is a base. Just kind of is a base. So we're going to start here and go 1, 2. Start here and go 1, 2. Nothing to fill in, so it's just me 0.4 meters. So now that we have all the units the way we want it, let's see about what equation we can use. So we're looking for impulse. Now, two equations that pop in my head for impulse is force times distance. And it also equals, remember, because of the little switch up thing up here, it can also equal, all the way down, mass times change velocity. So do we have force or time in our givens at all? Nope. So we're going to use our impulse equals mass times change velocity. So we're looking for impulse. We have mass. Mass is 0.08. And remember, our change velocity is final minus initial. Our change velocity is final minus initial. So our final is 0. Our initial is 6. So we have to do parentheses first. So that will give us a -6. So our impulse, to find our impulse, we're going to grab our handy dandy calculator and go 0.08 times -6. And that will give us a -0.48. And it could be, and since we're using math, so why don't we use kilograms meters per second. And that is our answer. There we go. So we did have extra information. So some problems might give you extra information that you don't need. And that's okay. Still write it down as a given. If you don't need it, you don't need it. But you never know. Here we go. So determine the momentum of, and it gives you a couple of things we got to do. So our equation for momentum is mass times velocity. So it says electron has a mass of that, and it moves that meters per second. So that is our mass, that is our velocity. I'm not going to write down givens and unknown for each one because they'll be the same. So we can just plug in 9.1 times 10 to the -31 times 1.18 times 10 to the 6. Now, on your calculator, Instead of dealing with times 10 to the messy stuff, you can just plug in with the E. So you have 9.1 capital E negative 31 times 2.18 capital E to the 6. And how you do that, when you plug that into your calculator, well, first you're going to do parentheses just to be on the safe side. You're going to plug in 9.1. You're going to hit second comma. Second, and the comma is right above the 7 number. So second comma, you should get a capital block E. You should get a capital block E. Now, on the calculator, there is a lowercase e button, but you do not want that one. Do not use that one. You want a capital E. You want to use the capital E. And you want to make sure you put a negative 31 in parentheses times parentheses 2.18 second comma to get that capital E 6. You can plug it in just like that. You don't have to worry about plugging in tens or anything like that. Enter, and you get that your momentum equals 1.98 capital E negative 24. So that's how the calculator will give it to you, but you know that that equals times 10 to the negative 24 kilograms meters per second. Kilograms meters per second. So that's telling you the same thing. So those are both the correct answer, just presented in two different ways. Now, a problem like this that you're having to deal with the E, I would raise my hand and get the graphing calculator. These other ones that you're just multiplying, you can use the Schoology calculator, but the ones that you have to use the E, I would raise my hand and get a graphing calculator if I was you. So then let's move to the next one. We have a bullet, which has a mass and a velocity. So momentum is mass times velocity. So that makes it 0.162 times 860. Just plug that into your calculator. And you get 139.32 kilograms meters per second. So then we have a 110 kilogram professional fullback running the line at 9.2 meters per second. So again, you have your momentum is mass times velocity. Mass is 110 times 9.2. 110 times 9.2. And you get 1,012 kilograms meters per second. One more. You have your mass. Passenger plane taxiing down a runway at that much velocity. So your momentum is mass times velocity. So you have 360,000 kilograms times 0.5 meters per second. 6123 times 0.5. And you get 0.123 kilograms meters per second. So there we go. So those are all our answers. It says which one of the above momentums is greatest? Hopefully you would see that it's the plane. The momentum of the electron is not very big because of the exponent is negative. This would be, so that would be your smallest. Your next one would be your bullet. The next one would be the football player, and then the next one would be your airplane. So the one that above it's the greatest is the passenger plane. And you just do that by looking at your momentums. How do you know if an object has the greatest inertia? It's the one with the greatest mass. So if we're looking at the above ones, which one has the greatest mass? Electron has a really small mass. Caliber bullet, fullback. So again, it'd be the passenger plane. And it's because it has the greatest mass. So if it has the greatest inertia, it has to have that equals the greatest mass. So there we go. So hopefully that helped you with momentum. If you have any questions, please ask Ms. Heath or Ms. Verona. Have a wonderful day. We have a couple of more videos, so keep watching. Bye.